Projected curve strategy has specific uses in manufacture, where you need to project custom paths on your surface to achieve best machining times and best results. Projected curve strategy projects a handmade curve on your surface so that it calculates the collisions. The projection happens against the copy of the curve, which is wrapped around the surface. I will delete the wrapped surface and show you how I did it actually. This curve I created with standard Blender modeling tools. I make a copy of this curve, but it has to be a linked copy. Linked because it has then the same data. And I add a shrink wrap modifier to it, and as a target I set my mesh surface. You can see now the projection is exactly on the surface, but the paths are not smooth at all. There are a lot of problems because of the geometry. So I have to switch on the last option of the modifier so that actually the projection gets applied only on the control points of the curve. Now the curve goes inside, but that doesn't matter for us, because these two curves are just used as a source for the computation, where BlenderCam computes vectors like these and sends actually the cutter against the surface. This allows you also on a 3-axis machine to mill with undercuts. I will calculate this path. Now I get the result. You can see that the result is pretty much standard result with correct offsets for a ball cutter, and but you can see that the paths are actually prolongations of the projection between these two curves. As you can see, with this method you can achieve a very smooth movement of the machine, which is also good for optimizing manufacturing processes.